Welcome to my talk on past designs as repositories of tacit and collective knowledge. This talk has been developed together with my colleagues Dr. Martin Stacey from De Montfort University and Dr. Mark Addis from the Open University. Designers refer to past objects all the time when they talk amongst each other. And while products or images of them are kept for a very long time, possibly forever, other representation associated with the products are not. So the object is essentially the repository of the collective knowledge of the past product, and often there is very little else. And in this talk we will argue that much of this knowledge is tacit. So I will talk first about design by adaptation being the normal mode of designing and how object references are shorthands in communication between engineers. I'll talk a little bit about the forms of engineering knowledge and tacit knowledge before I conclude about object references as a form of tacit knowledge. So let's start by looking at engineering design by adaptation. Essentially, in engineering practice, we have very little ab initio design, so it's a complete exception, and most designs are incremental designs from previous versions of the design. This is extremely important in engineering design because it's a way of reducing effort and cost and the risk associated with the design. And it's not only the design effort, but it's the planning effort for manufacturing, it's the thinking effort associated with it. And past designs play a very important role on different levels of abstraction, because sometimes it's the entire design that's being adapted, sometimes it's just individual parts or individual systems, sometimes it's only a solution principle that's being adopted, and sometimes it's the specific plans for the design that are being reused. And in the development of different designs, small differences can have far-reaching consequences. Here I've given you as an example the EH-101 Westland helicopter, which I studied about 20 years ago. And here you have got three helicopters designed for different customers with slightly different configurations. On the pictures you see that they have got different radars because they have different purposes. And these radars have huge implications across the entire helicopter because they affect the weight distribution. Essentially, a helicopter has to have its weight balanced to a central point underneath the radar. So if you add more weight at the front, you have to change the weight at the back of the helicopter. So they've got different tail configurations, and it has a huge effect on what it means for the fuselage to hang more or less weight on it. So you will see that the Italian helicopter has a whopping big radar at the bottom, whereas the Tokyo police helicopter has only got a very small one. And when I studied this company, the engineer would say, oh, we'll do something what we did for the Portuguese. And everybody seemed to understand it, and I didn't understand a word of what they're talking about. And I realized that the past objects were a very important way of them to. When the engineers say something like a nose like the one for the Italians, they are referring to groups of elements, and they're referring to relationships between elements. For it's very clear and convenient representations for those who know, and totally impenetrable for the rest. So it takes quite a long time for an engineer to understand the object references if they come as new members of a team or an organization. The challenge with this is that sometimes the scope of the reference is not clear, and people interpret into the reference what they want to. But object reference to a certain extent are also an inevitable way of doing it, because it is far too complex to explicitly explain a complex design. If you do it in a very abstract way, you miss the details. and long explanations would bias the arguments. If you look at this example, this is a picture of a diesel engine and all of the different options. You couldn't describe these options by going through this, but you can very easily say, oh, we'll have the configuration we used for JCB, and then you will see that it is a particular combination of all of the different thumps and crank pulleys and adapters and whatever else you have. So if you think of engineering knowledge from a company perspective, a company really doesn't care who has the knowledge, as long as the knowledge is somewhere in the organization and it's reasonably accessible. In that collective knowledge, what they need is technical knowledge to generate a product, but they also need the how-to knowledge. They need to understand how a product was designed and how the product was validated. They need to understand how their suppliers have been managed and the problems associated with this. They need to understand, for example, how to integrate and generate data. And this knowledge can be highly specialized within individual teams and with very little overview over the entire product. And if you think that in the design of a helicopter, you've got thousands of people involved in this at different places of the supply chain, and each of them know their own little bit very well. For example, there's a very, very specialized team that is designing the shape of the rotor plates, and they have that knowledge and they know very little about what's going on in the nose of a helicopter. So if you think of engineering knowledge from an individual perspective, we have got a lot of declarative knowledge that's taught at universities in a very conventional way. A lot of this is the underlying science and mathematics. Some of the individual engineering knowledge is very specialized technical knowledge. A lot of this is tools and methods that they will have learned, and engineers have a very good understanding of the different solution principles that apply in their own area of expertise. And engineering experts over the years acquire a lot of very specialized knowledge, and this arises often from specific problems. So they learn the knowledge together with the problems and the obstacles associated with them. And they have a rich knowledge of their own past designs, but also of the designs of their competitors, because of course they study them. And for example, diesel engine companies buy their competitors' engines and take them apart to understand how they've worked. But much of that knowledge that they acquire over the years is tacit. And the past objects really serve as a repository of knowledge, because the objects themselves persist for longer than any of the staff that remains in the company. And if you think back again to the helicopter example, the EH-101 has originally been designed in the 1980s, and they've been working on this until probably about 5 years ago, and there will still be engineers who are maintaining and upgrading various versions of EH-101s. So the original engineers have probably by now long retired. The object references encapsulate a lot of the solution principles and the configurations of a product, because it is very subtle how different things are being put together, what's the relationship, the size between them, the problems that occurred in them. And it would often be very difficult to pinpoint what has been the specific unique selling point or advantage of a particular design. But when you refer to it, people can construct this from the general knowledge that they have about engineering and some of their specific knowledge of the context. And this is often much, much wider and deeper than the intended reference, so that maybe I'll tell you, or we'll have a radar like the one for the Italians. And I just say this because I can't remember what the thing was called in detail. But maybe if I talk to an engineer, they'll think about a specific supplier, they'll think about a specific material, and bring in a lot of this very contextual knowledge. But there are also quite a lot of side effects of object references which are worth bearing in mind. That the designers might get a lot more than they have bargained on. One of the important phenomena is design fixation, which means that if we are familiar with how to do something, it's actually quite hard to unthink it and to free your thoughts and come up with a different configuration. And when people hear object references, they often don't stop and question the assumptions that are behind them. They just assume that it's done in the way that it's done. For example, they might assume that the same material is used, the same supplier is used, the same CAD system is used, but that was not at all implied. But in an object reference, you lose the original rationale for why something has been designed in the way that it is designed, and it might really no longer make any sense. For example, your supplier might not have had a machine that could give you a different shape, so you used the one that you had, and this is no longer a relevant constraint to you. And we also run into a big difference between experts and novices when they are interpreting object references. Experts have a huge body of reference objects that they can draw on, and they know which parts of the design they can modify and which they can't modify. But experts have also learned to shy away from difficult issues, so they become quite risk averse and might keep things that could be altered just because they don't want the grief that's associated with it. And that means in some ways that experts get stuck in their old ways, and they can actually become quite a block to innovation, and that it takes a new person who says, actually, we can do it in a different way, we don't have to do it how you've done it for the last 30 years, that really moves the design ahead. In engineering, it actually takes a very long time to become an expert. People say that it takes between 5 and 10 years to really understand the product and the processes and the company culture. So that if engineers move their jobs too quickly, they don't really become experts. And the deep expertise of somebody can take 15 years to acquire. For example, there are people who spend their entire professional lives calculating the holes on turbine plates to get the cooling air in, and they're absolute expert, and it's very, very subtle. It's really the exact shape of these holes, the positioning of the holes, and the angle of the holes, which determines whether they clog up or not, and therefore whether they'll ultimately cool the turbine plate or not. And this subtle knowledge takes several product generations to acquire, and there's only a new product generation developed every 5 years. So if you want 3 product generations, you have to have 15 years in the organizations, and that makes these engineering experts extremely valuable commodities in an organization. But what engineering companies also need and really struggle to get are the expert generalists, the people who are having an overview over the entire product. And especially with complex products, these people can be difficult to find, and they can be difficult to train. And here is an example, again, back from the helicopter company, who has got an overview over what, and we have people at a higher level who understand it on an abstract level, the entire product, and other people will only understand a particular system in quite a lot of detail. And the people who reach the top with a good generalist knowledge often have worked their way up from particular parts of the organization, and therefore they are biased towards a specialist understanding of the parts on which they have worked earlier. So if you want to abstract out from this, we can think of object references as being a way to chunk knowledge. And they chunk it in various different ways. On the one hand, you have got a hierarchical decomposition. So, for example, people might understand the overall elements that a helicopter have based on their experience with helicopters. So they know what the systems is. They can enumerate them on a fairly high level of abstraction. But they also can use object references to think about particular aspect of the product. For example, they can think about the function. The helicopter's functions is to lift or to transport people, but they can also use them to understand the form of something. So really quite subtle aspects of the shape of a plate or the angle on the nose of a helicopter, and they can think about particular systems that go across things. For example, the avionics system would be spread across an entire helicopter, and the way this would be done would be encapsulated in experiences of past helicopters. And these are large integrated chunks that very conveniently cut across a lot of the divisions. So if I say avionics system, like on the AH101, it will tell you something about the configuration, it will tell you something about where the sensors would be placed, but then it's context dependent. It depends on the specific AH101 I have in mind. And if I say, let's do the same thing we've done on the AH101, now 35 years down the line, I would have very different sensors. A lot of the things would be changed, but there might be something very specific that I'm still trying to communicate to you here. So this thinking in design chunks gives you a coherent mental representation that allows you to draw in different levels of abstractions and different aspects of the product. But it also triggers memories of the product. And these memories then in consequence almost put a context into your mind to think about. This can be very useful, but it can also, as I said earlier, be misleading. But object references as chunks give you the opportunity to think in really quite large chunks compared to an ab initio design. So if I say we do a functional composition of a helicopter, we would do it top down in a very abstract way, and we wouldn't have all of this very rich context we have by me saying we talk about the AH101. But the reasoning in chunks requires a lot of situated and experiential understanding of the behavior that comes out of this. And much of that is tacit. And now I'll talk a little bit about how this is tacit, but also how it's problematic to talk about this tacit knowledge. So with tacit knowledge, we basically seem to have two different conceptualization. One is that tacit knowledge is knowledge that cannot be explicated, or knowledge that is not explicated. And this difference is both philosophically and practically important, because as I said, object references are shorthand simply because it's too long to explain something. I cannot explain an EH101 to you, not even if I had an hour's talk or even if I had a year's talk. It simply is too complex, too many elements, too many behaviors, too many use cases. So you have to chunk it up in some shape or form. But also, sometimes the properties are extremely subtle, and some of the subtleties really quite difficult to bring out. For example, if I'm wondering whether I can put another sensor at a particular place in the fuselage, could it carry the additional weight? Would it be strong enough if I had a bumpy landing? So there are lots of issues associated with this. And the problem with tacit knowledge is, though, it clearly exists, but it's really quite difficult to explicate the exact nature of tacit knowledge, because it is so closely interwoven with the nature of expertise. And in the relationship between what knowledge is explicit and what knowledge is tacit and has to be tacit is very difficult to explain. So tacit knowledge is one of those concepts with very fuzzy boundaries. So to sum up, we can think of objects as carriers of tacit knowledge, because it's the way how participants in a company learn the patterns with which they work and the explicit knowledge chunks through which they can reason. So they become the sources of experiential learning. They'll create schemata, but also they'll bias the schemata in which you're thinking. They become triggers for recall of situated knowledge, and they form your mental models. They help you to envisage behavior, but potentially they can also be very misleading, because if we have nonlinear behavior and something changes, we might not be able to anticipate how things are affected. So object references are a powerful way of knowledge, but they can also be a bit of a two-edged sword.